This is semester 1 paper. The first question, free vibrations are vibrations of a constant frequency and a constant amplitude. Then the diagram below shows 4 sound waves. Which sound has the highest pitch? So highest pitch, you're looking at more frequency. So therefore, B is the correct option. So here you can see one wave is formed. Over here, 1, 2, 3 waves are formed. Here this is 1.5. And over here, there are 1 and 2 waves are formed. So highest pitch will be B. A graph plotted of V versus I for the ohmic resistor is a curve passing through the origin, a straight line not passing through the origin, straight line passing through the origin. So this is the correct option. So this is V, this is I, it will be a straight line. A main switch is a main distribution board is present in live as well as neutral. We have studied this, the double pole switch. Okay, so where the live and the neutral wire both are connected. Then a conductor AB is kept in the north-south direction of the Earth's magnetic field. So when this key is closed, this is positive and negative. So current is going to flow like this. Okay, so by the right-hand thumb rule, if the current is flowing in this direction, the needle will deflect there, that is west. So therefore, the needle will show deflection towards west. Okay, if you have any difficulty, if you have not understood, please stop me and ask. Okay. A coil wound around a piece of soft iron can become an electromagnet only when the circuit is open. The magnetic compass is present in the vicinity, galvanometer is connected to the circuit, current flows in the circuit, okay? So open circuit means when current is not flowing. Closed circuit means when current flows. Then, if water absorbs 4,200 joules to increase the temperature of 1 kg by 1 degree, the specific heat capacity will be, so this is 4,000 joule per kg per Kelvin. So if you want to convert it into grams, you divide by 4. So that is 4 joule per gram per degree Celsius. So therefore, this answer is the correct answer, the C answer, okay? Water is used in car radiators because it is a good conductor of heat. It conducts heat faster. Specific heat capacity is low. Specific heat capacity is high. So this is a good reason that we have studied that water has a high specific heat capacity. Fine. The heaviest nuclear radiation, okay, in this would be alpha. Alpha is heaviest. Nothing comes closer to this. Gamma has 0 mass, okay. Beta is an electron, but alpha particle has 2 protons, 2 neutrons. So that is definitely much, much heavier. Okay. Then to study the age of excavated materials, we use carbon, isotope of carbon. Okay, so carbon 14 is what is used. Fine. The diagram below shows a magnetic compass kept closer to coil AB, wood wound around a hollow cylinder cardboard. After studying the circuit and the magnetic compass carefully, state whether the switch S1 is open or closed. Okay, so they have left a gap over here. So that means whether the switch is open or whether the switch is closed. Okay, so imagine that if the switch was closed, current would be flowing like this. Okay, and according to the rule, this will be north and this will be south. So the magnetic field lines that will be formed will be like this. It will be, and therefore the compass needle, you can see that is pointing in that direction. Okay, so the compass needle is pointing such that the magnetic field exists over there. So therefore we can say that the switch is closed. Okay, the switch S1 is closed. That means the current is indeed flowing. Okay, so how did you arrive at that conclusion? Because the magnetic compass needle is pointing in the direction of the magnetic field, okay, which will be produced when current is flowing in the solenoid. Okay, what is the purpose of the magnetic compass in the above setup? Is to identify the direction of the magnetic field. Anyone has any question on this? Okay.
So what is the B answer? Can you repeat?
The B answer is, here this is just writing the switch is closed. And the B answer is what explanation I gave you, that the magnetic compass is pointing in the direction of the magnetic field created by the solenoid. Okay, also remember, if the switch was open, that means there would be no magnetic field. So in that case, the compass would have pointed in the north direction of the geographical north-south direction. Are you following that? Okay, the fact that the compass is pointing like this makes us believe that there is a magnetic field created by the solenoid. Do you understand that? Okay, so in the absence of magnetic field, the compass will point in this direction.
So if the compass was placed on the other side, which side would the needle deflect?
Okay, now if the compass is placed on the other side, remember one thing, a tangent to the field lines give the direction of the magnetic field. So if the compass is placed over here, the compass will point that way, like this way. Okay,
So we
because
write northeast.
yeah, means because north is formed on this side and south is formed on this side. That's the reason why the compass will be pointing this way. So if you have north and south and you draw the lines like this, okay, and at any point you want to find the direction of magnetic field, so the magnetic field will always be pointing tangential to the direction of the field lines. Do you understand that? Okay, so if you place a compass, the compass will point in the direction in the arrows that I've drawn. Is that clear?
Yes, sir.
Okay. Next question, give an important reason for copper to be used as a material of a calorimeter. It has low specific heat capacity, so it can take the temperature of the solution with itself consuming very less amount of energy. Okay. Then calculate the thermal capacity of 40 grams of water. So thermal capacity is mass times specific heat capacity. So this is 40 multiplied by 4.2. So this will give us 168 joule per degree Celsius. Okay, so this is the thermal capacity. Okay, then the next, this is a numerical over here. So this is a question in which they have given us the following information. They want the external resistance of the circuit, that means this total resistance. They want current I2, what will be the current flowing over here and what will be the current over here. So let us find the first thing. So 12 and 8 are parallel. So 1 upon R1 I can say, this is 1 upon 12 and 1 upon 8. So the LCM will be 24, 2 and 3. So R1 will be 24 upon 5 and that will give us 4.8 ohms. So therefore, the total resistance will be 2 plus 4.8 and that will be 6.8 ohms. So this total resistance is 6.8 ohms. Okay, now look here, this is very important application. So over here, current 0.4 is flowing only in this branch. So therefore, the potential difference V equal to IR will be 0.4 multiplied by 12 and that will be 4.8 volt. So 4.8 volt is the potential difference across this. Because they are connected in parallel, it will be also across 8 ohms. So this is a very important application. So V is equal to IR. So 4.8 is equal to I into 8. So I will be 4.8 upon 8. This is I2 for us. So this will be 0.6 amperes. So I get this as 0.6 amps. So this I have got as 6.8 ohms. This is 0.6 amperes. So this is a very simple logic now. 0.4 amperes and this is 0.6 amperes. So obviously this has to be 1 amp. So 1 ampere flows in, out of that 0.4 flows up and 0.6 flows down. So that is the reason why I is equal to 1 ampere. Okay, any questions in this?
Do we have to write a statement like a potential difference across two parallel resistors is same?
Yeah, the potential difference across parallel resistors will be same and the current in resistors in series will be same. So over here, R1 and R2, I will be same. And if you have R1 and R2 connected parallel, so the voltage will be same across them.
So the voltage is not same in series?
Voltage will be different. Here V1, V2, okay, that will be different. If the values of R1 and R2 are equal, then the potential drop will be same. Do you follow that?
Yes, sir.
Okay. Moving ahead now. So 3 wires are there with the proper color coding are connected. So this is earth wire. Okay. Which one is this?
Live wire.
This is live.
No. Mute.
Okay. Can anyone answer this?
No, so
No,
B
BS
is
is
live.
neutral and C is live.
Live. Okay. So which one will be brown?
So live.
Live.
Brown will be C. Green will be
A.
and light blue will be B.
B.
Okay. Why does it become colder after a hailstorm during or before the then during or before the hailstorm? Okay, so this is again application of high latent heat of fusion of ice. Okay, so when ice melts, it takes the heat from the surrounding. Okay, and 1.6 336 into 10 to the power 3 joules per kilogram. So for 1 kg of ice to melt, it will take that much of heat from the surrounding. And so when after the hailstorm, okay, it becomes much more cooler than while or before the hailstorm, because when the ice melts, it takes a lot of heat from the surrounding, which leads to the drop in temperature of the surrounding. Okay, the
So is it
second,
necessary to mention the amount of heat that it will take, like 33?
yeah, it is. So when you say that ice has a very high latent heat, it is good that you write that value as well. And the second is the reason what I told you. Okay, because ice takes this heat from the surrounding to melt, the temperature of the surrounding drops. So there are always 2 points in this reason. Even for the case of water, there are 2 points. So water has a high specific heat capacity, and so water absorbs more heat, and then the reason. Okay, it is a good radiator. It cools down the engine. Those reasons you can write. So in the first point, you know the value, please mention this. You can also mention it in the form 336 joule per gram. Okay, any unit is fine, but do mention that. Okay, two bodies have same specific heat capacity, then they will always absorb the same amount of heat if the temperature increases by the same amount. State whether the given statement is true or false. So over here, they have the same specific heat capacity. So that means I'm going to use this space. C1 is equal to C2. Okay, same specific heat capacity. They will absorb the same amount of heat, that is Q1 is equal to Q2, if their temperatures increase by the same amount, that is delta T1 is equal to delta T2. Now, is this statement true or false? So if Q1 is equal to Q2, that means M1 C1 delta T1 is equal to M2 C2 delta T2. So C1 is same, delta T is also same. That means M1 is equal to M2. So what does that mean? This statement is true only assuming that mass of the two bodies are equal. Does everyone follow that? If you take two bodies which have the same specific heat capacity, and you take both the bodies of same mass, then and you give them the same amount of heat, then their rise in temperature will also be same. Yes, someone was saying something.
So, but since the mass is not mentioned that it's equal, so can we write that it's a false statement since mass is not equal?
No, that is again your assumption, na, that the mass is not equal.
Yeah.
So that's what I'm saying. You can say that this is true only in the case where mass is equal, rather than saying it is false because mass is not equal, because that would you making an assumption. Okay. Anyone else has any question? Okay, Gia, you followed this. We discussed this yesterday also. Okay. Now, the next question, a metal piece of mass 420 gram present at 80 degree is dropped in 80 grams of water at 20 degree in a calorimeter of mass 84. Find if the final temperature is 30. Okay, so let me prepare this table. So you have metal, you have water, and you have calorimeter. So mass of metal is 420, mass of water is 80, and calorimeter is 84. Okay, so then you have the initial temperature as 80, and this is 20, this is 20. The final temperature is 30. So therefore delta T is equal to 50, 10 and 10. Okay, so the heat that is lost by the metal will be gained by water plus the calorimeter. So I will write over here M1C1 delta T1 is equal to M2C2 delta T2, sorry, plus is equal to M3C3 delta T3. So for water, it will be 80 into 4.2 into 10 plus copper calorimeter will be 84 plus what is that? This is 200. So I'll take it as 0.2 into 10, that is equal to 420. Now we have to find this heat capacity into 50. Okay, so I'm just using a calculator to get an answer. This is 80 into 4.2 into 10. Okay, so that gives me 3360, and 84 into 0.2 into 10 gives me 168. So therefore 3360 plus 168, when I divide that by 420 into 50, I get the value of C as 0.168 joule per gram per degree Celsius. Okay, if you want to write it as SI, that will be 168 joule per kg per Kelvin. That is the answer. Anyone has any question in this?
So in this case, the heat energy is lost by the metal piece, right?
Yeah, the heat energy is lost by metal and absorbed by water and calorimeter. Okay, don't forget to write the statement. Assuming that no heat is lost to the surrounding, heat lost by the hot body is equal to the heat gained by cold body. Okay, moving ahead. Rohit plays a flute and Anita plays a piano, emitting sound of the same pitch and loudness. Name one characteristic that is different for waves of the two instruments. So the quality is different. Okay, that means the nature of the waveform produced by the flute and by the piano are different. Then, if now the loudness of the sound from flute becomes 4 times that of the piano, then write the value of the ratio of amplitude. So loudness of flute and piano is 4 is to 1. That means the amplitude of flute is to amplitude of piano is 2 is to 1. Okay. Anyone have any difficulty? You know that loudness is proportional to the square of amplitude. So therefore the answer is 2 is to 1. Okay. This is definition. You can refer to the textbook for the definition. Then name two factors on which the force experienced by a conductor carrying current placed in a magnetic field depends. State how these factors affect the force. So I have told you this formula F is equal to VIL. So the force experienced by the conductor depends on the magnetic field, depends on the current, and the length of the conductor in the magnetic field. So if you increase the strength of the magnetic field, the force will be more. If you increase the current, the force will be more. Okay, so there is a direct relation in this. So with the help of which rule can you determine the direction of force? So that is Fleming's left hand rule. Okay. Then nuclear energy. Again, this is a textbook question. After emission of a nuclear radiation, the atomic number of the daughter nuclei increases by 1. Identify this. This will be beta. Write a nuclear reaction indicating nuclear change mentioned below. So you have A. So this will become Y. Okay, so this can be written. Name, what is the special name given to the parent and daughter nuclei? Yeah,
So for Q, we can write energy also, right?
yeah. In place of Q, you can write energy. Name this special name. That is it is the isotope. Okay,
The isobar, right?
isobar. Yeah, because the Z value is changing. So isobar you have to write. Okay, then an application appliance which is rated 440 watt 220 volt is connected across 220 volt supply. Calculate the maximum current through the appliance. So P is equal to V into I. So therefore 440 is equal to 220 into I. So I will be equal to 2 amps. Resistance. So we have P is equal to V square by R. So R is equal to V square by P. So 220 upon 440. This is 2 za, that is 110 ohm will be the resistance. Okay. This is for 3 marks. So 1 mark will be for correct substitution, this or this, and 1 mark will be for the final answer with unit. 1 mark will be here for final answer with the unit. If you forget the unit, you lose the marks. Okay, below diagram shows a vibrating tuning fork E mounted on a sound box. When the vibrating tuning fork A, B, C, D are placed on the sound box Y, one by one, it is observed that a louder sound is produced for tuning fork B. So you can see that it is 320 hertz and it produces a louder sound with E. So what is the frequency of E? 320 hertz. Why does B produce a louder sound? Because B is resonating. That's a shorter way. Remember, this is 2 marks. Okay, so therefore your answer will be E is making B undergo forced vibration with a frequency that is equal to its natural frequency. Therefore, B produce vibration with a larger amplitude, and that will make the air inside this vibrate with a larger amplitude and will produce a louder sound. Okay, be mindful of the marks, students. From the graph of heating curve given below, state the melting point and boiling point of the substance. So if I label this as A, B, C, and D, okay, this and this is a plateau. It's a horizontal line. Therefore, it is change of state or phase change. So phase change happens twice. One, when it is going from a solid to liquid, and second is from liquid to gas. So therefore, this has to be solid to liquid, and this has to be liquid to gas. So therefore, 40 will be the melting point, and 160 will be the boiling point. Okay, so you just have to identify that. So this will be 40 degrees Celsius. This will be 160 degrees Celsius. Okay, it's only that will give you one mark each, that is 2 marks. Here, if I call it as A, you know that 235 is equal to A plus 4. And if I call it as B, so B is equal to 90 plus 2. So this will be easy for you to get to the answer. A is equal to 231. B will be equal to 92. So this is 231 and 92. Okay,
Can we do it without?
Yeah, working is not required. You have to rewrite this expression with the correct answer. This I was showing what you mentally do or what you can do on paper. Remember, it's a simple chemistry. Okay, so whatever is on the left, the same has to be totaled on the right. So whatever is over here, the same has to be totaled on the right. Okay, so that's the point.
So in the graph,
Yeah.
so can we write freezing point?
The question says melting point, so you have to just answer that. The answer is
Okay.
40 and 60. Only one advice I will give you is don't just write 40 and 60. Okay, write over there melting point.
Yes, sir.
And 40 degree, or at least write one below the other, 40 and 160, and write the unit also, degree Celsius. Okay, fine. Then coming to the next question. Study the above figure and answer the following. What type of vibration does the above figure represent? So it is damped vibration. State one reason for which the amplitude of vibration decreases with time. They have to overcome the resistance of the medium. So energy is spent and therefore the amplitude keeps on decreasing. Give an example of natural vibration. So remember to use the word vacuum whenever you're talking about natural vibration. So like striking a tuning fork in vacuum or letting a pendulum oscillate in vacuum. So those are examples of natural vibrations. A certain beam of alpha, beta, gamma radiation travels through a region of electric field produced by two oppositely charged plates, A and B, A being positive, B is negative. So the question is, which of the following three has a maximum speed? So we know gamma. Okay, gamma is an electromagnetic radiation. It travels with the speed of 3 into 10 to the power 8 meter per second. Which one deviate the most from its original path? That is beta. Okay, beta being lighter will be easily pulled toward the positive plate. Which one does not deviate at all? Again, this is gamma. Gamma is electromagnetic radiation. They are not affected by electric or magnetic field. So, simple question. If a wire has resistance of 2 ohms and it is stretched to thrice the original length, calculate the new resistance. So that will be 3 squared into 2 that is 9 into 2, that will be 18 ohms. Remember, when a wire is stretched to 3 times its length, so this is the area of cross section, this is the length. So the new length is 3 times the length, and the new area of cross section is 1/3. So therefore, resistance is resistivity length upon area of cross section. So the new resistance will become 3 times the length, and area is 1/3. So 9 times the original. Okay. So you don't need to show this working, but at least show this part. Then,
So can you explain the A part again?
yeah, if the same wire is stretched to 3 times the length, so the length becomes 3 times, but the wire will also become thinner. Do you agree with that?
Yeah.
So the thickness, the area becomes 1/3. And therefore, if this wire has resistance R, this wire will have resistance 9 times that of R. Okay, so if a wire is stretched to twice its length, then the resistance will become 4 times. If the wire is stretched to 3 times the length, the resistance will become 9 times. In the same way, if a wire is folded, that means if the length of the wire is made half, so if this is L and the new wire is L by 2, then its resistance will decrease by 4 times. Okay, is that understood?
Yes, sir.
What will happen to the specific resistance? It will remain unchanged. Specific resistance is only affected by temperature and the material of the wire. So this is the end of the Sem2 paper. Now we will start with the other one. Okay. Before we go ahead, I'm giving you this meeting ID and passcode, because once this meeting gets over, you have to join with this. So